AI with Sally, a podcast that takes a closer look at some of the most interesting technology stories on artificial intelligence and machine learning. We'll hear about the latest in hardware and software that has a big impact on the world of AI. I'm your host, Sally Ward-Foxton. Welcome back to AI with Sally. Today's episode is brought to you by our sponsor, Display Week 2024. In this episode, I'll be having a chat with Untether's Bob Beachler about the company's automotive strategy, including its recent chiplet partnership with ARM. That's coming up a bit later, but first, here is some AI news you might have missed from eetimes.com. AI chip startup Grok has gone viral. The company has attracted a lot of attention by targeting developers with its very low latency LLMs running in its custom silicon-powered cloud. I went over to Grok's new office in Mountain View to chat with Grok CEO Jonathan Ross about the change in direction. He told me the company doesn't sell hardware anymore. They're becoming a cloud provider. This was always part of his plan, he said, but he didn't think it would happen quite so soon. So the company doesn't sell chips anymore. Instead, it will partner with companies to set up and deploy commercial clouds based on Grok's rack-scale computers. One of the deals it's signed is with the Saudi state-owned oil company Aramco, which together with other deals should see 240,000 Grok chips deployed in the near future. To read the whole of our conversation, head over to eetimes.com. Edge AI chip startup Halo has launched a new chip designed to accelerate generative AI models in edge devices. Halo CEO Or Danon told me recently that the new Halo 10 can run Llama 2 7B at 10 tokens per second with less than 5 watts of power, or Stable Diffusion 2.1 at under 5 seconds per image in the same power envelope. In terms of compute, the Halo 10 has similar or slightly less compute than the previous gen Halo 8 and around 20 tops Int 8 performance, but it has new support for Int 4, which can double throughput. Compared to the vision-focused Halo 8, the new chip has a different balance of compute to memory with a lot more memory. And while the Halo 8 already supported transformers, support for common transformer operators has been improved for generative AI workloads. Check out that story for more details on eetimes.com. This month, I've also been speaking to New Reality, who want to replace the host CPU in data center AI inference systems with dedicated silicon that the company says can cut total cost of ownership and power consumption. The Network Addressable Processing Unit includes hardware implementations for typical CPU functions like the hypervisor. I had a chat with New Reality's CEO Moshe Tanak, who gave me the details on the microarchitecture. You can read the details on eetimes.com, but overall he said he wants to enable 100% utilization of AI accelerators by removing all the CPU bottlenecks. So far, New Reality's chip supports AI accelerators from AMD, Qualcomm, and IBM. Before we get to the interview, here's a quick message from our sponsor, Display Week 2024. Dive into the future of display technology at SID Display Week, happening May 12th through 17th in San Jose. Explore cutting-edge innovations, get hands-on with groundbreaking products, and learn from global visionaries. You can register for Display Week at displayweek.org. Canadian AI inference chip startup Untether started with data center cards with its first-gen chip, but is now also targeting edge applications with the chiplet offerings on its roadmap, including automotive. Automotive is an unusual sector for a chip startup to play in, so I wanted to follow up with Untether's VP product, Bob Beachler, to find out in a little more detail what the automotive AI landscape looks like right now and what the company's plans are. Okay, hi Bob, and welcome to the show.
Hi, great to be here.
So Untether, you've always had an automotive kind of focus, and you've always had automotive on the roadmap. But I think with this latest announcement, things are starting to get real. You recently announced that you're working with ARM, so your Untether's AI accelerator is going to be compatible with ARM's automotive CPUs. Tell us a bit about why you've decided to do this.
Sure. Well, it's really a good match because what we've been doing is energy efficient AI compute, right? And so we're looking for ways to be able to, for example, extend the range of electric vehicles by using less energy to do the AI compute for autonomous vehicles. And of course, ARM's claim to fame has always been its low power processors. And ARM does have a significant foothold in the automotive marketplace through a lot of its partners today, whether that be Qualcomm, whether that be Renesas, Socionext, and the like. So it made sense as ARM was looking at their roadmap and trying to see, okay, what's happening in automotive compute. And what we're seeing is that the amount of compute is growing dramatically, driven by AI and autonomous vehicles. And ARM saw a kind of a need for them to be able to offer a package deal that has not only their CPUs, but also some AI co-processing to go along with it. And so we started talking with them several months back about how do we go about doing this. And so it really, made a great sense for us to partner with ARM to offer a joint automotive solution to the tier ones and OEMs.
So when you say a joint solution, what's involved in making sure that everything kind of works together?
Yeah, so what we're seeing is that first it's going to be kind of a chiplet-based approach. That's really where things are going. And again, that's all about energy conservation. Rather than having a discrete CPU blasting stuff over PCI Express to a separate chip, we're looking at compatibility at the chiplet level using the UCIe specification. But beyond just that physical layer of UCIe, there is a lot of protocol that has to happen. There's a lot of things on the functional safety side that have to happen. So, for example, just the simple act of who's going to boot first. Does the CPU boot and then wake up the coprocessor? Does the coprocessor boot itself and then tell it it's ready to go? How's that communication going to happen? And what's the protocol that's going to be used for that? Now, ARM has a lot of expertise in this area, having done CPUs with, small IP coprocessors on die, now extending it into the chiplet domain. And so there's a lot of collaboration in that regard, both on the communications protocol and then also on functional safety. Because you have to look at functional safety as a system level approach, not just, each chiplet individually.
Got it. When it comes to things like who boots first, though, is this dictated to you by ARM, or are you working with ARM to develop that kind of specification, or how does it work?
It's a collaborative effort between the engineers and then also with the customers as well. Because the automotive customers have a lot of experience in doing this type of thing, and so we work kind of in a three-way partnership between ourselves, ARM, and the end customer to ensure, is this the functional safety concepts that you want to have? Does this make sense to you? Because you can't just create it in a vacuum. You need that customer input as well.
Absolutely. While we're on the topic of ARM, I mean, you're a RISC-V company. Is ARM happy about that? I assume they didn't object to the fact that you're based on RISC-V?
Yeah, I don't know, can't comment on what they think specifically. Okay. But I'll make it clear, the reason that we, our first generation of chip, we rolled our own RISC processor.
Yeah.
Okay, this was before kind of RISC-V came to prominence. We have specific needs for AI processing and our unique at-memory architecture that requires us to create a bunch of custom instructions. So we have, over 30 custom instructions that we need in order to make our machines work, efficiently. And that's something that the RISC-V ecosystem had embraced. ARM, you would need an architectural license to be able to modify their ISA. And so that's why, at least as a startup for us, RISC-V was the path of least resistance. But that doesn't preclude using ARM. To us, we're agnostic necessarily about the ISA itself. We just need to be able to modify it heavily for our needs.
How has it been working with customers in terms of, automotive OEMs and these tier ones? Are they ready to accept RISC-V versus any other ISA or versus ARM, which has kind of been proven in functional safety for a lot of years? Like, how do they feel about RISC-V?
They are okay with it as long as you have the necessary functional safety concepts.
Okay.
Right. And so, for example, there's not a whole lot of off-the-shelf RISC-V IP that's automotive grade. So we at Untether have to do that work ourselves to put in the necessary safety concepts. And when we make our automotive chiplets, will probably have what's called an ASIL D, as in dog, chip manager, and that will be off the shelf, and that may very well be ARM based, depending upon what we end up choosing. We need something there that's really got functional safety aspects nailed down solid.
Sure, absolutely. And we'll come to functional safety a bit later on, but first I want to ask you about the workloads and demand for AI in vehicles in particular. I think currently this is mostly driven by ADAS type of applications, or do you think AI in vehicles is driven by ADAS today?
It is certainly ADAS and autonomous vehicles as you go up the level stack, level 2 plus, 3, 4, and 5. Yes, it's really driven by AI. And because for processing not just your vision workloads from the cameras, but also your LiDAR, your radar, your ultrasound, there's an entire sensor suite now getting into these cars that all of them will have their own kind of neural networks that they need to use. An example is with bird's eye view. If you've seen, the new cars, and you get in your car and then you go to park and all of a sudden you can see the top of the car. Well, you don't actually have a camera there.
Yeah.
What you have is stitching together all the different cameras to put that bird's eye view together. Now what people are doing, they want to do object detection on that bird's eye view. So there's a specific neural network that runs in that mode. And then when you start getting on the freeway, you may be using different neural networks. So that's driving it. Now, with that being said, as we look towards the future, start looking for large language models to get into the car.
Oh, yeah?
Yeah. And particularly in the IVI, the in-vehicle infotainment systems, you're going to do a lot more conversing with large language models in the cockpit.
Amazing.
So that the car doesn't have to phone home, right? As we know, cell phone connections still aren't that solid. So you're going to see, in the next 5 to 10 years, you'll be driving around you'll have these large language models in your car ready for you to converse with.
I like the idea of being able to converse with the car while driving. But are you also seeing transformers in vision and perception, vision transformer and things like that?
Yes, absolutely. So as an example, that bird's eye view that I mentioned, there's a specific neural network called BEV-former, BEV former, and it's a vision transformer for bird's eye view camera view. So we're seeing that for sure. People are looking at them, and it's a debate. And I say it's a debate. For example, you could look at doing a Swin transformer versus the Conv Next. They both do the same functionality. They both have similar accuracy, but one takes a lot more compute than the other. So each OEM in tier one really tries to differentiate their products now based upon the networks that they use and how they train them.
For you then, as an AI accelerator provider, you got to be what? You got to be fast, you got to be flexible, you got to be power efficient. It's a difficult ask, isn't it?
It is. And it's a fine line between having that general purpose capability. I say general purpose in the AI space, right? We can't run generic, C code workloads, right?
Yeah.
We run neural networks. But yes, you have to be general purpose, and you have to be looking towards the future, right, as well, because the networks you see today are not the networks you're going to have 3 years, 4 years down the road. When we saw, when we generated this second generation product, we absolutely saw vision transformers coming down the pike, and we put in some specific circuitry to help with some of those transformer style workloads that we wouldn't use for convolutional networks, but we would use for vision transformers. And then the other thing you have to watch out for is that if you get too specific, okay, I've made a chip that does only this. For example, using two sensors to do 3D imaging, as an example. I'll pick on somebody generic like that. That's a use case, but it's not the only use case. And if you make a chip that only does stereoscopic vision networks, you're in trouble, because what about BEV-formers? What about these other things that the customer wants you to do. So you do need to have that kind of general purpose aspect to it. The other thing you want to watch out for is your accuracy. And so what data types are you using? Because that will influence how accurate you can run these neural networks.
Yeah, for sure. I guess the requirements in terms of stuff like latency are a bit different for different vehicle applications. I was thinking about the chatbot in the car that I'm conversing with versus actual perception systems. The requirements, I guess, are a little different. Like, I don't need the real-time response necessarily from the chatbot, right?
Yeah, I'll give you a great example of that. So for large language models and MLPerf as an example, they have a latency requirement on the order of 200 milliseconds, I think, in order to submit, right? And that's still faster than human perception.
Okay.
And so that's perfectly fine for large language models. But for an emergency braking system in a car, the latency requirements is 30 milliseconds. It's an order of magnitude faster.
Yeah. Yeah.
Right. And so, yes, those requirements are quite at odds.
For sure. Yeah, for sure. All right, let's talk about safety. How do you do automotive functional safety in an AI accelerator? And how do we make AI functionally safe? I feel like this is a can of worms, but I'm interested to hear what you think.
It is kind of a can of worms, and the ISO working group, the ISO 26262 working group, has an AI group that's trying to solve this problem, but can't wait that long, right? We have to solve it beforehand. So there's two aspects to it. First, just the silicon aspect. How do you make functionally safe silicon? And that's pretty well known in the industry. We've been doing it for a long time. What are your safety concepts? What types of ECC do you have on your SRAM? Are you doing lockstep processing? There's a lot of those types of techniques that are already known from a silicon standpoint. Now, when you get to the neural network and the AI at a system level, now things get a little more difficult because by definition, a neural network isn't necessarily deterministic, right? It's a statistical model.
Yeah.
Now, if you give it the same picture, it'll give you the same results, but you're never going to get the exact same picture that it was trained on because, lighting changes, weather, wherever you're driving. So how do you skin that, right? Which is, how do I know that my neural network is going to be accurate enough and good enough for to be safe? So you go back and look at one of the silicon concepts, which is redundancy. So in silicon, right, you want to do two things in parallel, compare the result and see if it makes sense. You could do the same type of thing in neural networks. And what you would do is, for example, run two different neural networks. So I used an example of Swin Transformer and ConvNext. I'm going to run both of those in parallel. And if they both give me the same answer, then I have a pretty high confidence level that that's what I'm seeing, right? Because I have two different neural networks, both giving me the same result. So yeah, we're seeing that more and more, that people will run a multiplicity of networks simultaneously in order to get to that level of confidence and safety.
Yeah, I guess for neural networks, one of the things a concept I personally struggle with is they're like 99% accurate or 99.9% accurate, like by definition almost. You're kind of choosing the accuracy level when you quantize or whatever. So if you know it's not going to be 100% accurate all the time, I guess where's the cutoff, or how do you decide like what accuracy you need?
That's a great question that I don't have the answer to. Because just look at it, right? People are deploying these things now, and they're not 100% accurate.
Yeah.
Right. And we see reports all the time, whether it's, the latest is Ford Blue Cruise is under investigation. Tesla's been under investigation. Mm-hmm. Cruise took their cars off the market, and now they're starting to come back. And it's all the growing pains about how good can you make these autonomous vehicles and the ADAS systems, because they're not going to be that accurate. I say not that accurate. They're not going to be 99.9% accurate. When you look, for example, with the MLPerf, That 99.9 means I only have 1% degradation from the floating point 32 version of the network. That network in and of itself is not 99% accurate. At best, it might be, like ResNet 50, I think, is 89% accurate or something like that. Mm-hmm. Still better than a human, but not 100%.
Yeah, I guess, as a person who doesn't know much about this, am I stressing too much about this 99% accuracy that I'm going to get from my neural network? When I personally am driving my car, am I 99% accurate in everything that I do? I don't want to tell you what I think the answer to that is, but it's certainly true that we're holding these systems to a higher kind of level of scrutiny, or to a level of accuracy that humans can't achieve, right?
That's right. And there's a theory. I say it's a theory. I haven't really investigated it, but I've heard people talk about it, that if you were just today, take the existing autonomous vehicle systems, take all the humans off the road, and just have robo-taxis as an example, autonomous vehicles, you would have a lot less deaths and a lot less injuries. Because guess what? Your computer doesn't get tired. It doesn't have a big meal. It doesn't have 2 drinks with dinner. It's going to be better than humans overall. But when you have, for example, we'll pick on Ford with the Blue Cruise, they have 2 cases of fatalities. And what people are saying is like, okay, well, this is unsafe. Well, no, the person driving it was unsafe. They weren't paying attention to what was going on. You can't necessarily just turn these things on and then not look at them.
Yeah.
At least when for those types of things where they've specifically said this is not full autonomy. You need to pay attention. And Ford even has cameras that look into people's faces and make sure that their eyeballs are looking at the road. And as soon as they vary and wander, alerts go off.
I think I need that for sure. Okay. What about functional safety when it comes to chiplets? Does the chiplet-based design have to be functionally safe at I don't want to say system level, but at the level of, at the package level, let's say?
Yeah, at the level of their communication. So yeah. Last summer, UCIe came out with their 1.1 version of the specification that specifically addressed automotive use cases. And it has redundancy and monitoring of that communication, so that in the situation where the signal may degrade for whatever reason, I mean, again, we're making stuff to last at least 10 years in the automotive case. So stuff will degrade.
Yeah.
So it has automatic monitoring and rollover to redundant channels. And then if it finally, gives up and says, okay, this is getting to be untenable, error messages get thrown. The car goes into what is commonly referred to as limp home mode,
yeah.
where, right?
Yeah.
It can only go 30 miles an hour, and you take it into the shop and you have to replace the CPU.
With the extra kind of functional safety that's required for these chiplet-based designs, I guess you got me wondering, why do we need chiplet-based designs for automotive at all? Wouldn't it be easier and safer just to have single chip designs where you can kind of qualify the whole thing all at once?
Well, certainly if you could get away with a single chip, that would be okay, but it's not realistic.
Okay.
Right now there's tens or hundreds of CPUs in a car. And what we're seeing with the rise of the AI workloads, that a heterogeneous compute system with domain-specific architectures, having your CPU and then having your AI accelerator, is the only way that you're going to get enough compute to be able to do these types of use cases. You can't make an all-singing, all-dancing single chip. It absolutely is going to require multiple chiplets.
One thing that we sometimes talk about with chiplets in other markets is that if they're kind of off the shelf, you can kind of put them together and it'll be quicker to do that. It'd be quicker to make a design, a heterogeneous compute design, if you use chiplets. But as obviously the automotive sector is not known for moving very, very fast when it comes to these kind of, vehicle designs take 5-10 years to come to market. So
Hmm.
Is shortening the time to market, do you think that's a reason that automotive OEMs are favoring chiplets?
Not really.
Okay.
Um,
they're,
they're
they're happy with the
favoring
10 years.
yeah. They're favoring the chiplets again for the energy efficiency and the compute density. The time to market, as you mentioned, the automotive marketplace does work something on geological time.
Right.
They take a while, and rightfully so, because it's a really complex system, and they want it to be as safe as possible. Um, and the concept, that we have a chiplet marketplace today, that doesn't exist. Part of the reason we did this partnership with ARM is because we see that, oh yeah, we can both use UCIe, but that doesn't mean they're going to be compatible.
Yeah.
There's a lot of other stuff, as I mentioned, that goes into this, that we have to work in tandem to make sure that this system works. Perhaps, many years in the future, we'll have that type of ecosystem where it'll just work. I use PCI Express as an example.
Yeah.
PCI Express has been around long enough that everything is pretty much plug and play, and the protocols are well understood. But with UCIe, we're not quite there yet from a standardization standpoint. And so that's why we need to have these partnerships between the AI accelerator companies like ourselves and the CPU vendors like ARM.
Can you tell me a little about who your customer actually is? Is it the OEM? Is it one of these new AV type companies? Is it my classic German OEM, or is it a tier one somewhere? Like, what kind of customers are you engaging with on this?
Yes, kind of all of the above.
Okay.
Making a chiplet system is not cheap. Like I said, we don't have the ecosystem yet that they're plug and play. And we're talking about, okay, somebody's got to design the substrate. I'm going to select this CPU, this AI accelerator, this memory, design that package, fabricate it, test it out. It's tens and hundreds of millions of dollars to make these systems. So you're really talking about tier ones, or the OEMs are the ones that are doing this, or the robo taxi folks, the autonomous vehicle folks that have deep pockets to be able to do these types of systems.
In that kind of scenario, you'd provide what, their die, and then they assemble it? Or?
That's right.
Okay.
That's right. In the case of ARM, right? So ARM's an IP provider. We're a chiplet provider,
Mm-hmm.
or a chip provider. So what they would do is license the IP from ARM, make the CPU, and then we provide the die of our accelerator, and they do the integration.
Mm-hmm. Okay. I know you said the automotive OEMs, the designs at least, move at a sort of geological pace. Just as a kind of as an aside, I know that can be really tough for startups to kind of get into the automotive market, which is why not many do. Untether actually is one of very few that actually is going for this
Mm-hmm.
market. You already have offerings for the data center. I guess my question is, why does it make sense to go for automotive at all, given how hard it is, or how much harder it is than any other application?
Well, it goes to one of your earlier questions, which was general purpose AI compute.
Yeah.
Our technology does that and is scalable. So I can make data center class chips, or I can make chiplets for automotive. And it makes sense to be a multi-market approach. So in our case, we start with our commercial grade products. That's what we have today with our Run AI and our Speed AI. But we definitely, there's a screaming need for AI compute in automotive, and we feel that we can satisfy that. So it makes total sense for us to make an automotive grade product in addition to our commercial products.
Okay, with this glacial,
and we have the backing, and the other thing is that we have the backing to be able to do that. Whether it's General Motors has been a strategic investor in Untether AI. We've raised $130 million US, so we had the financial wherewithal to be multi-market and make multiple different types of chips.
Okay, last question then. I know we said the pace is glacial or geological, as you put it, for OEMs, but how soon before we'll get an Untether chiplet in a vehicle that's on the road?
Right now, I would say that we're looking at the 2028 model years. So what is that? That's 4 years from now. 2028, 2029. That's kind of the right time frame that we're currently engaged with customers looking at moving to this type of approach in that time frame.
I cannot wait.
You're right. As a startup, boy, I can't wait that long for revenue. So that's why we have commercial products as well.
Yeah, I was going to say, I can't wait to have a conversation with my car in 2028. I think it sounds like a lot of fun. Okay, thanks so much, Bob. Really enjoyed our chat.
Oh, thank you. It was great catching up.
Thank you very much, Bob Beachler, VP Product at Untether, for being on the show. This episode of AI with Sally was brought to you by Display Week 2024. Thank you very much, Display Week, for sponsoring us. That brings us to the end of the episode. Please tune in again next time to hear more news and views on AI, machine learning, and the technologies that enable them. If you're listening to this on the podcast page at eetimes.com, links to articles on topics we've discussed are shown on your left. AI with Sally is brought to you by Aspencore Media. The host is Sally Ward-Foxton and the producer is James Eade. Thank you for listening.